Hello, and I want to welcome you to an introduction to polynomials. We'll first start off by discussing what a polynomial is, types of polynomials, the degree of a polynomial, evaluating polynomials when variables are equal to a value, and simplifying expressions by combining like terms which are also using polynomials. So let's get started. What is a polynomial? Turns out it is a finite sum of terms of the form a times x to the nth power, where a is a real number and n is a whole number. Okay, so now that we know what a polynomial is, let's talk about the types of polynomials you may encounter. They include monomials, binomial, and trinomials. So, what is a monomial? It is a polynomial with one term. And to see an example, that would look like 2x or 2x squared or something like that, where it's just one term. What is a binomial? It's a polynomial with exactly two terms. An example, 3x plus 2. See, there's going to be one plus or minus present, denoting that there is a binomial present. For a trinomial, as you might guess, it is a polynomial with three terms. And an example would be x squared plus 3x plus 8. Okay, now let's talk about the degree of a polynomial. A degree is the highest number for the exponent. Highest exponent value in polynomial. So if we look at some examples that say find the degree of the polynomial, if we look at A, we have negative 2x squared plus 3x plus 6. Looking for the highest exponent value in the polynomial. As we see, the exponents are here, and this has an exponent of 0. So the highest exponent is 2, so the degree is 2. For B, 15x minus 10. The only exponent found would be the 1 for the x right there, so the degree is 1. 1 is the highest exponent found in that expression. Then finally look at C. This has an exponent of 1, 7x plus 3x cubed plus 2x squared plus 9. If we look for the highest exponent, we're going to see that 3 is the highest exponent found for any variable in that expression. So we have a degree of 3. Now, let's evaluate polynomials when values are equal to denoted variables. So the directions will say evaluate the following polynomials. Okay, so for part A, it says 2x plus 5 when x is equal to 2. All you have to do is take the value it gives you and plug it in for x and evaluate what you get. So 2x plus 5, let's let x equal 2, so we'll plug a 2 in for the x and we'll just evaluate. 2 times 2 is 4 plus 5, and when we get that, we're just equal to 9. Okay, and then for whenever x is equal to 0, let's rewrite our expression. Let's plug a 0 in for x. So I have 2 times 0 plus 5. Anything times 0 is 0 plus 5, so it's equal to 5. Let's go to the part B. Where we see an x, let's plug in a 2. So let's plug a 2 in for that x. So we have 3x plus 2. Then we'll plug in the 2 for x. So 3 times 2 is 6, plus 2 is 8. Okay, now it says when x is negative 1. I'd like to rewrite the expression. Where we see an x, we'll put a negative 1 in there. So 3 times a negative 1 is a negative 3. And we'll add 2. So negative 3 plus 2 is negative 1. And then finally, for part C, we have a trinomial. So everywhere we see a 1, let's plug, every time we see an x, let's plug in a 1. So x squared plus 2x plus 1. Everywhere we see an x, we'll place a 1. So 1 squared is 1, plus 2 times 1 is 2, plus 1. When we evaluate that, we're going to get 4. Okay, and then over here, when x is equal to negative 2. So I like to start by rewriting the expression x squared plus 2x plus 1. Everywhere we see an x in the trinomial, let's place a negative 2. So negative 2 squared plus 2 times negative 2 plus 1. Negative 2 squared is equal to 4. Okay, and positive times a negative is a negative. So we have 2 times 2 equal to negative 4. And plus 1. And when we evaluate that, we just get 1. Because 4 minus 4 is 0, plus 1 is 1. And finally, let's talk about simplifying expressions by combining like terms. We have polynomials, and we need to combine like terms. So combining like terms. For part A, we have 2s minus s. As you know, there is a 1 in front of every variable. It does not have a coefficient already in front of it. So we have 2s minus 1s, or 2 minus 1 is equal to 1, and we'll attach our s to it. So it's 1s or just s. For part B, we have same bases, x to the third, x to the third. So let's just combine. 33 plus 5 is 38, and then bring our x to the third around. Okay, for C, we have some more complicated stuff. We need to find all the stuff that has the same x to the same exponent. So I like to start off by denoting that everything found in this expression has the same variable raised to the same power. And I'm going to box everything that has x to the fourth found in it. So 5x to the fourth, I'm going to box 2x to the fourth. Right, and then the other stuff that we can find is x to the third. So everything that's x to the third, I'm going to circle it. And then 4 is left alone because it does not have anything else similar to it. So we combine 5x to the 4th plus 2x to the 4th plus 3x cubed minus 2x cubed plus 4. So we combine these two terms because they are alike. 5 plus 2 is 7x to the 4th, right? And 3x to the 3rd minus 2x to the 3rd is a minus x to the 3rd plus 4, and that's simplified. If we look at D, let's go through and did what we did earlier and find things that are similar. So this first term, 4x squared y and 6x squared y are similar. Alrighty, so now we have 5x y squared, and we have a negative 3x y squared in common. So let's bring these new terms together because they are similar. 4x squared y plus 6x squared y plus 5x y squared minus 3x y squared plus 2. And when we simplify, 4 and 6 will give us 10. Let's attach the same variables with it. Over here, we simplify a 5 and a minus 3. We have 2. Attach our variables. And then we're just left with plus 2. Right, and finally, our last example, we have 9 plus 2 times the quantity 4c minus 2. Okay, what we need to do is to use the distributive property first to start working with what we have. So 9 plus 2 times 4c plus 2 times the negative 2 found right there in the parentheses. Let's go through and simplify. 9 plus 2 times 4 is 8c, and then a positive times a negative gives us a negative, and then 2 times 2 is 4. We simplify. Notice that there's only one c right there, and the others are just regular rational numbers. So 9 minus 4 is 5, a positive 5, and then just bring the 8c on down.